Hello class, today we're looking at reflections. Our essential question is, how do I identify and draw reflections? Our learning intention, I'm learning to identify reflections, rotations, and translations, and to identify points after a transformation, and to draw transformations. So we're looking for the image point after the transformation. Pause the video and see if you can do the next two warm-up problems. You need to look at the chart of rules that you were given to be able to identify what happens. Pause the video now, please. I hope you tried. So if we are looking at a 270 degrees counterclockwise rotation, we know that the X and Y are mapped to Y and the opposite of X. Think about where you're starting. If you're starting in this quadrant, 270 degrees takes you 3/4 the way around. So we know that for this, -6, -3 is mapped to. First thing you do is change them around. So this will be -3, -6. Second thing you do is to negate your X. So this goes from a -6 to a +6. And we're done. Okay, what was the rule for a 90 degrees counterclockwise rotation? Well, your X and your Y are mapped to the opposite of Y and X. So 7/4 is mapped to. Change them around. 4, 7, and negate the 4. Negate your Y. So it's -4, 7. Okay, can you identify the translations? What has happened in that first translation? Which has changed, your X or your Y or both? If I'm looking, these are my X values. This is not moved over right or left, so my X stays the same. But for my Y, I have gone from here up to here. So I have moved up 1, 2, 3, 4 spots. So that is Y plus 4. And those are supposed to be V's on the edges. Okay, any questions? Okay, for the next one, you need your ruler and you need to decide where the points go. We're going to translate by -2, 7. -2 means it goes left 2 and up 7. So I'm going to go left 1, 2. I'm going to go up 1, 2, 3, 4, 5, 6, 7. So this becomes I prime. Now, I can easily find E prime because it is directly below and it's just one box below. Now, I'm going to count for M again, or I could just look. Once I find one point, I can find them all. This is up 1 and right 3. So I'm going to go up 1, 1, 2, 3. This will be M prime. And then I go over 2 and down 1, over 1, 2, down 1, and this is X prime. I'm ready to connect my dots. because this is a rigid motion. I want to make sure I look and make sure that those look exactly the same size and shape. Rigid means we don't change size, we don't change shape. We simply move it around. We could also reflect it though for a rigid motion. Okay, reflections. Think about looking in a mirror. In a mirror you see your reflection. So when we look at reflections in geometry, the reflection is a transformation across a line called the line of reflection, such that each line of reflection is the perpendicular bisector of a segment that would join a point with its image. So that tells you it's going to be right down the middle of those two reflections. So it's a transformation across a line. And that's the line of reflection. Such that it is a perpendicular bisector of each segment. I'm going to use the symbol for perpendicular. And these segments join a point with its preimage. And its image. So we're starting with the original point. The line of reflection will be exactly in the middle. So if you were to draw a line from each point and its image, it would be the perpendicular bisector. So if we're going to reflect over an axis, we've got to realize that means that it will be the same distance on the other side. So as I'm looking, here's my point of origin. 1, 2, 3, 4, 5, 6. I've got to go down. 1, 2, 3, 4, 5. Actually, it's only 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So, here is our M prime. W prime will be right above it. Over here, I'm over 1 and up 6, so I go over 1 and down 6 to get D prime. This is over 1, 2, 3, 4, up 1, 2, 3. So I'll start here, I'll go down 1, 2, 3, and this will be my A prime. Using my ruler, I am going to connect my dots. Visually, I'm going to check and make sure it looks exactly the same. Except flipped over. So, they're exactly the same shape, but their orientation is different. So pause the video and see if you can reflect over the y-axis. Can you reflect this over the y-axis? Okay, the y-axis is here. Once again, I'm going to count. I'm looking at this. I go 1, 2, 3, 1, 2, 3. This becomes A prime. I'll put it on the other side because it'll reflect over into it. Okay, this is 1, 2, 3, 4, 1, 2. 1, 2, 3, 4, 1, 2. This will be S prime. This one is clear over to 1, 2, 3, 4, 5, and down 1, 2. Go over 1, 2, 3, 4, 5, down 1, 2. T prime. And then finally J is over 1, 2, 3, 4, down 1, 2, 3. Connect your dots. I do hope that you tried to do this one on your own and were successful. If not, you might need more practice. Okay, so if we're going to reflect over the line y is equal to negative x, what does that line look like? We need to draw the line or at least show where the line's at. Okay, so when x is 0, y will be 0. When y is 1, x will be negative 1. When y is 2, x will be negative 2. So if you're looking, your line of reflection is a diagonal of your Cartesian plane. So we draw that diagonal. Now we're ready to get started. Now that I have that line drawn, I'm going to look and I'm going to count again, but this time I count at a diagonal. So here's H, this will be H prime. Here is Q, here will be Q prime. Here's L, and L prime. I forgot to mark Q prime. Here's P, and here will be P prime. Okay, so have I got them all marked? I think I should have used a different color than black because it's awfully hard to see. I didn't do Q prime right because it's not going to give me that. Okay, so here's Q. Should be up here. Still don't think I've got it quite right. This doesn't erase very good. I did the copies at home. So if I'm looking here, I've got to go add a perpendicular bisector. If I'm down at P, I've got to do that perpendicular bisector, which will put it, this is 2, 2. Put P right here. So that one was off a little bit. Okay, measuring always helps when you do a measurement. Okay, here's P. Oh, L. I think I've got L pretty good though. This is, yep, L was good. So let's connect our dots. Remember, this is not professional, because I would do a perpendicular bisector on each of these. Okay, that doesn't look too bad now that I made a mess of the rest of it. Next time, remember, we need to, when we draw, we need to be able to measure. Okay, so now on this one, we're wanting to find the midpoint of two of the points. We could actually use we use our compass and do it if we wanted to. So let's get a compass and try. Our perpendicular bisector has to be equidistant. So I'm going to put on this and I'm going to draw a line, an arc. I'm going to come over to the other point, draw an arc. Where they intersect will be the exact same distance from the 2 points. I'm going to do the same thing with P and P prime. Now remember, where they intersect is going to be that line of reflection. So my intersect point is here, and I will draw a line to connect them. And that would be my point of reflection. Now, if I wanted to do this one better, I would have used the compass, and I would have used a ruler, and I would have had a perpendicular line that went between every one of the points. So, using a line of reflection, we have to make sure we measure correctly, or use the compass to make it a little bit more accurate. You know you're successful when I can identify reflections, rotations, and translations, and to identify points after a transformation, and to draw the transformations. So this is mainly about transformations. Specifically, reflections.